Okay, so let's take a look at practice quiz 5, number 4. It says find a differential operator that annihilates the given function. So A, we have fx equals 5x cubed minus 2x squared plus 5x plus 1. So let me write theorem 10 here. So, okay, so theorem 10 had two parts, but this is the first part. It says d to the n annihilates x to the k for k less than or equal to n minus 1. So again, recall the d means derivative. So we want to annihilate the highest degree in the x here is 3, so we need to go one higher than that. So it looks like d4 should be the answer. So pretty much if you took the fourth derivative of this guy, it would end up being 0. Because the first derivative of 1 would be 0, the first derivative of 5x would be 5, second derivative of 5x would be 0, first derivative of 2x squared would be 4x, second derivative would be 4, third derivative would be 0, and this one, the first derivative would be 15x squared, then it would be 30x, then 30, then 0. So you can see if I took the derivative 4 times, this would disappear. So therefore, d to the fourth is our answer. So L equals d to the fourth is the answer. Okay. Okay, so I'm going to show it here. You don't have to show it for your quiz, but I'm just going to show you to give you some intuition. So I'm claiming that d4 of our f function should be 0. Okay, so d4 can be broken up as d3, then d times f. So if I took the first derivative of this guy, it would be 15x squared minus 4x plus 5, which I have here. Then it'll be d cubed of this guy. I can write that as d squared and then bring a d inside. Take derivative again. So derivative of 15x squared would be 30x, then minus 4. Then I'll have d squared times this, bring a d in. So it'll be d of derivative of 30x minus 4. And it's just going to be derivative of 30, which is 0. Okay, so you see d to the fourth annihilates my f. That means it makes it 0. Okay, let's do part B now. So I'm going to erase part A now and we'll do part B. Okay, B, this time we have fx equals 3 e to the minus 2x cosine of x minus 5x e to the minus 2x. So to do this one, we're going to be using theorem 10 and 11. So let me state those here. Okay, so here's theorem 10. D minus alpha to the n annihilates x to the k e to the alpha x for k less than or equal to n minus 1. And theorem 11, d squared minus 2a d plus a squared plus b squared to the n annihilates x to the k e to the ax cosine bx and x to the k e to the ax sine bx for k less than or equal to n minus 1. Okay, so looking at this part here, applying theorem 11 to that, we can see then that looks like our a will be minus 2 and our b will be the coefficient in front of the x here, just 1 here. Let's note that. Okay, so the a would be negative 2, the b would be 1. Notice there's no x in front of the e here, because over here you have an x. So you can think of it as x to the 0, because x to 0 is 1. So therefore, to get my n minus 1, then if it's going to be 0 here, it looks like the n would have to be 1. So plugging into this, then it'll be d squared minus 2a, or a is minus 2, d plus a squared, which is negative 2 squared, plus b squared, so 1 squared, to the first power. That would annihilate this guy here. Okay. Now, this guy does not have a sine or cosine in it, so we will not use theorem 11, we'll use actually theorem 10 on this one. So looking at this one, looks like we have a 1 as the exponent on the x, and looks like our alpha value will be minus 2 here, so let's note that. Okay, so using theorem 10 then on this guy to annihilate this, the alpha will be minus 2. And the exponent on the x is 1. So to annihilate that, you need to go 1 higher on your n, so it's going to be 2. It's going to be d minus a minus 2 squared, then will annihilate this guy. So now I want to annihilate both of these at the same time. So to annihilate both of them, you can just multiply them together. So let me write that here. Okay, so this guy simplifies as d squared plus 4d plus 5, and this one simplifies as d plus 2 squared. So the product of these two will annihilate my f. So this guy here. So this would be your answer. If you wanted to check that it does annihilate it, I guess it'd be a pretty tedious calculation. You have to multiply all the stuff out and apply it. I'm not going to do it here, and you do not have to do it for your quiz. Just need to give me the annihilator. So this would be the answer for part B. Okay, so let's go on to part C now. So let me erase a few things and we'll go on to part C. Okay, so here's part C. So we have to annihilate 2x squared plus 1 plus sine of 7x. So let's first annihilate the 2x squared plus 1 guy here. Well, it looks like the third derivative, or d cubed, should annihilate this because the third derivative of 2x squared plus 1 would be 0. So let's note that here. Okay, so the d cubed would annihilate the 2x squared plus 1. Now we need to annihilate the sine of 7x. Okay, to do that, we have theorem 10, 11, and actually corollary 2. And we're actually going to apply corollary 2 down here. It says d squared plus b squared to the n annihilates x to the k sine bx and x to the k cosine bx. So in our case, it looks like the b is going to be 7. And there's no x in front of the sine, so you can think of it as x to the 0. So therefore, we just need to, or n would be 1 in that case. So therefore, b is 7. Let's apply corollary 2 then. Okay, so again by corollary 2 then, with b being 7 and n being 1, because there's no x here. So you have to go, the highest part on the x, you have to go 1 higher than that for your n. Well, since it's x to the 0, 1 higher is 1, so it's 1 here. So it's going to be d squared plus my b squared. And to annihilate both of these at the same time, well, let's multiply them together, so that should be your answer. So let's write that. So hence then, d cubed, L equal to d cubed times d squared plus 49 will annihilate our f up here. So that's our answer. Okay, so we're done with part C. So we're done with practice quiz 5 number 4. So let's leave the video here. Okay, so we're done.